This is Lecture 8, Calculating Estimates, Graphing Estimates, and Interpreting Estimates. By the end of this lecture, you should be able to know how to calculate and interpret estimates when focusing on dummy variables, know how to calculate and graph estimates in SPSS when focusing on continuous linear variables. At this point in the semester, you should have a good idea as to why we use regression analysis. We have a dependent variable and independent variables we think influence our dependent variable. Regression analysis allows us to determine if our independent variables actually do have a statistically significant impact on our dependent variables. At this point in the semester, you should know how to interpret a regression analysis in SPSS. If not, go back and rewatch lectures 4, 5, 6, and 7. In this lecture, I'm going to review how to make multiple regression estimates and interpret them. I will go through the process more slowly and in more detail, as you will have to know how to do this for your final research paper. Consider the following hypotheses. On average, democracies have a higher GDP per capita than dictatorships do. Next, as ethnic fractionalization increases, GDP per capita decreases. In order to assess whether these hypotheses are supported by the data, I ran the following model in SPSS. GDP per capita is the dependent variable. It can take on any positive number value. Democratic regime is the first independent variable. It is a dummy variable. It takes on a value of 0 for non-democracies and a value of 1 for democracies. I expect this variable to have a positive impact on GDP per capita. Ethnic fractionalization can take on any value between 0 and 1, with higher values indicating that a country is more fractionalized. I expect this variable to have a negative impact on GDP per capita. Here are the results of the analysis. The coefficient for democracy is positive, which is what I expected, and it is significant at the 0.05 level since the significance value for the coefficient for democracy is less than 0.10. And since democracy is a dummy variable, as it only takes on values of 0 and 1, I can interpret the coefficient for democracy as follows. All else equal, GDP per capita is 5097.831 higher in democracies than non-democracies. The coefficient for ethnic fractionalization is negative, which is what I expected, and it is significant at the 0.001 level since the sig value for the coefficient was less than 0.002. Since it is a continuous variable, which means it can take on multiple values, I can interpret it as follows. All else equal, as ethnic fractionalization increases by 1, GDP per capita decreases by 19340.217. Now on to making estimates. You will make estimates for each independent variable. The first step is determining if the coefficient for the first independent variable is significant. So if it is not significant, you cannot make any estimates, so you should move on to the process for making estimates for the next independent variable. If the coefficient is significant, you can make estimates. You should start by writing out the regression equation. Then, if the variable is a dummy variable, you will make 2 estimates, one for each category of the dummy variable. Then you will interpret those estimates. If the variable is continuous, you will make estimates across all values of the independent variable and graph the estimates against the independent variable in SPSS. Then you will interpret the graph. So now I'm going to go through this process with the regression I ran earlier in the lecture. The first step is writing out the equation. Based on our regression results, we have GDP per capita hat equals 5097.831 times democracy minus 19340.217 times ethnic fractionalization plus 19290.170. Our first independent variable was democracy, and the coefficient was significant, so we can make estimates. The variable was a dummy variable, so we will make 2 estimates. One estimate will be for the 0 category, and one will be for the 1 category. So to do this, we start with this equation here, and we will vary democracy and set ethnic fractionalization constant at a certain value. Note that if there were additional independent variables in this model here, we would also set them equal to a constant value as well. So, what should we set ethnic fractionalization equal to? It could be a minimum value, a maximum value, or an average value. So, to find the minimum, maximum, or average value for ethnic fractionalization in SPSS, you can run Descriptive Statistics in SPSS. In SPSS, click Analyze, Descriptive Statistics, Descriptives. This window should pop up. You place your variables in the variables box. In this case, I put ethnic fractionalization in the variables box, denoted as frac_eth in SPSS. I move it over and click OK. These are the results of your analysis. So I'm going to set ethnic fractionalization constant at its average, 0.44971. So I rewrite my equation here and replace ethnic fractionalization with 0.44971. Next, I write two new equations, one where I replace democracy with 0 and one where I replace democracy with 1. So for my first equation, we get 5097.831 times 0 minus 19340.217 times 0.44971 plus 19290.170, which equals 10592.681. For the second equation, we get 5097.831 times 1 minus 19340.217 times 0.44971 plus 19290.170, which equals 15690.512. The next step is to interpret these values. The first equation tells me the average GDP per capita of non-democratic countries with an average ethnic fractionalization. So I can say non-democratic countries with an average ethnic fractionalization should have 10592.681 GDP per capita on average. The second equation tells me the average GDP per capita of democratic countries with an average ethnic fractionalization. So I can say democratic countries with an average ethnic fractionalization should have 15690.512 GDP per capita on average. When interpreting your estimates, make sure to indicate what values you set all the other independent variables to. Now that we're done making estimates for the first independent variable, we can move on to the second independent variable. Our second independent variable was ethnic fractionalization. It was significant, so we can make estimates for it. And it is continuous, so we would calculate estimates in SPSS and graph them in SPSS. So to do this, we start with this equation here. And we will vary ethnic fractionalization and set democracy constant at a certain value. Note that if there were additional independent variables in this model, we would set them equal to a constant value as well. We could use descriptive statistics in SPSS to find the minimum, maximum, and average value of democracy, but since we know it's a dummy variable, it's probably best to set it equal to either 0 or 1. I will set it equal to 1 just for demonstration purposes. So now it's time to enter this equation into the variable creator in SPSS. Click Transform, Compute. Type your equation in the numeric expression box. You should have absolutely no spaces in this equation. So here's my equation. I have 5097.831 times 1 minus 19340.217 times ethnic fractionalization Now note, when I write ethnic fractionalization here, I need to use the name that SPSS uses for ethnic fractionalization. So in this case, this here, frac_eth, is what I used in my analysis. So I should move it over here. Then I have plus 19290.170 in the target variable box, put the term estimate. If you have already made an estimate for another variable, type in estimate 2 or estimate 3. If you do not follow these rules, SPSS cannot make the appropriate estimates for you. Click OK. When you are done, you should go to the Data View tab, go to the very last column, and find your new estimate variable. If it is not there, you did something wrong. If so, repeat these steps. Make sure you have no spaces in the equation and make sure you use the variable names SPSS uses in the equation. Now it's time to graph the estimates. Click Graphs, Legacy Dialogues, Scatter Dot, choose Simple Scatter. Place the estimate variable in the y-axis box. Place the independent variable you varied in the x-axis box, in this case frac_eth, and click OK. You can copy and paste the graph right into a Word file. The last step is interpreting the graph. You should describe the general effect the independent variable has on the dependent variable in the graph. Make sure to indicate what values the other variables are being held at constant in your interpretation. So for this graph, we can say in democracies, as ethnic fractionalization increases, GDP per capita decreases.